For this question, we have two cars, P and Q. They leave from the same point and travel in the same direction. We're told that Q leaves at time t equals 0, which was shown on the graph. Q is leaving at t equals 0. And then we're told that P leaves a second later. So here is P, and that leaves 1 second later than Q. So then it says, the figure shows the velocity time graph for P and Q, and then we're trying to work out what is the distance between Q and P when t is equal to 8 seconds. So t is equal to 8 seconds is obviously here. We're trying to work out the distance between Q and P when t is equal to 8. So the area underneath a velocity time graph is displacement. Now we're told the cars are going in the same direction, so they're just going in a straight line, and they're not turning back. We can see from the graph that we have here, the velocity is not becoming negative, so they're going in a straight line forwards and not coming back. That would mean that whatever the displacement is equal to is the same thing as the distance. So the area underneath this graph is just the distance. It would be different if the velocity became negative. If the velocity became negative, that means the car is going forwards and then comes back, and then our displacement would not be the same thing as distance. But in this case, we don't have to worry about that. So we're trying to work out the area underneath these two graphs for Q and P, work out the difference between the two areas, and that will then be the difference in distance traveled by Q and P. So let's start with Q. So for Q, it's straightforward. This is just a triangle, what we have here. And the base of this triangle, so we're using half base times height. The base is 8, and the height is 40. So then the area here will be 160 meters. So for P, we can split this up into two shapes, a triangle and a rectangle. So for the triangle, that's this bit here. The base of this triangle is 2 seconds, as it goes from 1 second to 3 seconds. And the height is 20. So then our area would then be a half base times height. And then we have this rectangle here. So the base of our rectangle is 5 seconds, from 3 to 8. And the height is again 20. So we're adding 5 times 20 onto the area of the triangle. That will give us the whole trapezium, which is then 20 plus 100, so 120. And then if we find the difference between the distance for Q and P, we end up with the answer, which is 40.